All right, Liberty North AP and dual credit psychology. Good morning. It is Wednesday, October 28th, virtual Wednesday. Today we're going to be going over unit number 3, AP learning targets 6 and 7. Also, before we do that though, I'm going to go over again the directions for part 2 of your unit 3 lab, which is your family genogram and map. So again, part 1 was to diagram your family from your grandparents down to you, and then label any nature or genetic influences on you. Okay, so then you're just to identify genetic things, biological influences on you. Okay, all right, so part 2 is the nurture side of the assignment, in which you're going to map 3 main environmental influences, relational influences on you and your family. All right, you're going to map conflict with the squiggly line. You're going to map alignment, which basically means there's a special bond or a connection or a relationship that might exist between 2 people or more. And then boundaries, which are naturally occurring or family created boundaries or divisions between people or groups of people. Okay, so I just have some examples up here which you can look at just so you can see. So I just drew them in this family. So you've got conflict here. I got conflict between son and mom, but I also have conflict between uncle and entire family. All right, so just examples that, you know, conflict can be anywhere between any groups of people. Okay, now it doesn't have to be currently there might not be anything going on, but if there's consistent, frequent, reoccurring conflict, you probably need to put it in. And then of course there could be situations in which there's conflict that exists currently right now in your family. Okay, alignment is basically, again, if there's a special bond or relationship. First thing you guys need to do is one of you or all of you need to put the parent in which you are aligned to. So again, in psychology, we believe that it's nature, it's a genetic influence, but you're going to be aligned to one parent or the other. Now that does not mean at all that you have that you don't have a good relationship with both parents and that the other parent, it's a bad relationship. It's not what it all means. It's just, you know, you have a connection with. So, you know, I always tell students, think about it if you're away in college, who's the first parent you would probably call? Okay, so here we have, I'm aligned with my grandfather, my mom, my brother's aligned with my dad. We're aligned with each other. Okay, so and then you can have also alignment with groups of people. So if you have one side of the family that's just all really, really close, they can be all aligned together. Okay, and then lastly is boundaries. So if there's any environmental created or natural occurring boundaries that exist. Okay, so my mom and her older brother have a boundary around them because younger brother was most of the time off someplace else, so he has a boundary around himself. So boundaries are very common around people, single individuals, especially in our culture. And then you can have boundaries that exist over entire sides of the family or multiple people. So again, if you have a divorce in your family, you're going to have, you know, a lot of boundaries, stepsisters, half brothers, half sisters, you're going to have boundaries. Okay. And then again, if you have a brother or sister who's off in college, they'll have a boundary around themselves because of distance. Okay, they are away from the family. All right, so it can be because of distance, situations, and so on and so forth. Okay. All right, so that'll be your lab. Now, once you get part 1 and 2 done, don't forget you got 2 questions to answer, which are on your lab instructions. So you have to identify nature and nurture influences on you, and then whether they have high or low adaptive value. Okay, so don't forget to get that done, but then also get your two questions, required questions answered. Okay. All right, we're going to move over here. All right, and we're going to be doing learning target 6 and learning target number 7. Okay, so we'll start out with number 6, and I've got some page numbers on here for you as well, because there's some really good diagrams in your book. All right, number 6 is identify basic processes and systems in the biological basis of behavior, including parts of the neuron. Okay, so we're going to focus on the neuron on number 6. All right, so what I have here is page 86 and 87. First thing we need to do before we get to the parts is know that there are 3 types of neurons. All right, and then what I've got is basically what they do and then where they are in my nervous system. Okay, so we have sensory motor and interneurons are the basic neurons and nerve cells. Okay, so neuron means nerve cell of the nervous system. My sensory neurons are in charge of input, which means they're in the peripheral nervous system. Okay, so my sensory neurons bring information in from my environment. They bring it into the central nervous system. Okay, so that's input. My motor neurons, which are also in my peripheral nervous system, are in charge of output. Okay, so anything then that my brain and my nervous system, my central nervous system feels needs to be communicated out to muscles, organs, or glands, it's going to use motor neurons to do so. Okay, all right. And then in the central nervous system, brain and spinal cord, we have interneurons. And what they do is they're in charge of processing. Okay, so the thinking, the analysis, the interpretation that goes on in my nervous system. Okay, so the correct order would be sensory, intermotor, right? Input, processing, output. Okay, in any action. And then we're going to do a relay race tomorrow in class, in which we kind of map that out and kind of show you how that occurs. Okay. All right. If you have your books available, or if you have your online book, obviously you can have it to page 78, figure 9.2. Let me get that up here real quick in the book. Okay, so part 2 of AP Learning Target number 6 is the specific parts of a neuron. Okay. All right, and here is a awesome diagram, which I will hold up here as I talk. Okay. So this is, again, on page 78. It is figure 9.2. Okay, and what you have is you have your diagram of a neuron, the basic cell of the nervous system. Okay, and it's pretty good. All right, and what it's going to show you is the parts you need to know, which are the dendrites, which are my receptors of the nerve cell, my cell body, which houses the nucleus. Then I have a long connector between the cell body and my axon terminals, which is called the axon there in the middle. It is covered by my myelin sheath, okay, which is kind of like an insulated covering, protects the axon and the cell. And then I have my axon terminals, okay, my terminal branches, which hold and house my neurotransmitters, okay? So the big red arrow shows you the direction in which a cell fires, right? So information or neurotransmitters from a previous or a sending neuron, all right, are taken up by the dendrites over here, okay? Then it goes to the cell body or the nucleus, which decides whether the cell is going to fire or not. And then it travels down the axon to my axon terminals and my terminal branches, which then will release the neurotransmitters, okay? Okay, so page 78, figure 9.2. All right, and then up here I have, again, the 5 parts that you need to know, okay? And I have them listed in order that a neuron fires as well. So you have your dendrites, which are your receptors, okay? So each neuron, each nerve cell, we believe, you know, it's hard to quantify because you have billions of neurons in your nervous system, has about 15,000 plus connections with other neurons, okay? So those dendrites are branches and they spread out and they make connections with thousands of neurons, okay? So they are my receptors, so they bring in neurotransmitters that have been sent and they bring them to the cell body, which is where the nucleus is, the brain of the cell. The cell decides whether it's going to fire or not, and then it sends its signal across the axon to, which is insulated by the myelin sheath, to my terminal branches, which hold the neurotransmitters, and then the cell will fire, okay? All right? Okay, so that is AP Learning Target number 6, okay? Pages 86, 87, and 78, all right? You've got your 3 types, and you got your parts of the neuron, and a great diagram, okay? All right, AP Learning Target number 7. Identify the basic process of transmission of a signal between neurons, okay, or neural transmission, okay? That's pages 79 to 83, and there is a great diagram, figure 9.4 on page 81 that I'll be showing you here in a second, okay? All right, just some basics. Most of these are vocab terms. Neurotransmitters are the chemical messengers of the nervous system, okay? So just like we talked about, hormones are the chemical messengers of the endocrine system. Neurotransmitters are the chemical messengers of the nervous system. Okay, so every neuron builds, stores, and supplies and communicates neurotransmitters, okay? Now, neurons do not touch, all right? So even though if I say a cell has thousands of connections, all right, the connections are maintained by proximity, all right? There is no touching, no connection. So we have a synapse or a synaptic gap, which is between all neurons, okay? So although they are connected, they do not actually physically touch, okay? And then action potential, which is a big term, okay, which basically refers to the firing of a cell, okay? The neural impulse that travels through a cell. Now, you need to know that that is an electrochemical process, okay? So electricity, so my neurons are actually all charged, right? And then electricity or a current does flow through the neuron, causing it to fire and release neurotransmitters, which are chemicals, okay? So with the technology that we have today, we can see the electricity, the kind of spark of neurons when they fire, they light up. We can also hear it. It's called popping, neural popping. Okay, with the technology that we have. Okay, so they believe that you have enough electricity in your brain to power a 12-watt light bulb, which is kind of what's in your refrigerator. Okay, so electrochemical. So electricity travels through the neuron, and then it releases neurotransmitters, which are chemicals. So we have an electrochemical process, which is action potential when a cell fires. Okay, now, when we have action potential or neural impulse and firing, three things happen. Number one, we have reception, and this all kind of happens in the synapse, okay? So basically, the book uses the example of serotonin and dopamine producing neurons. So they're gonna fire serotonin and dopamine, okay? Those neurotransmitters are gonna cross the gap, all right? And they're gonna be received or communicated by the receiving neuron, all right, in their dendrites. All right, once that happens, we're gonna have reuptake, okay? So not every neurotransmitter that is serotonin, dopamine is gonna get communicated on or received. So there's gonna be some left in the synaptic gap. So the sending cell then is gonna perform a process called reuptake, in which they're going to kind of suck up and replenish their neurotransmitters, okay? Then, if there are any neurotransmitters still left or anything left in the gap, enzymes are going to come in and digest all of that, because the cell, under normal circumstances, will not fire again until the synaptic gap is clear, okay? So it's going to fire. We're going to have action potential. Neurotransmitters are going to be released into the synaptic gap. They're going to be received by the other neurons and their dendrites. It's going to replenish, suck back up, reuptake anything that's left over from the serotonin and dopamine. And then if there's anything left in the gap, enzymes swoop in and digest it so that the gap is clear. Then once the gap is clear, that's the end of the refractory period. So that's a vocab term. So my cell needs to recharge, replenish, okay? And then the gap needs to be clear, and then the cell will fire again, okay? So we do have a brief refractory period in which all that needs to take place. Now, it happens in milliseconds, and we'll do a relay race between classes Thursday and Friday, all right? And we'll kind of show how fast this happens. So my endocrine system is not built for speed, but my nervous system is built for speed. And this happens very, very quickly, okay? So on page 81, you have figure 9.4, all right? Sorry, I can't get my projector on this morning. Okay, which does and shows you a great diagram and an up-close image. So it shows you your neuron. Okay, it shows you the parts of the neuron, the dendrite, cell body, axon, axon terminals, terminal branches. It shows you how it's connected to another neuron. And then it shows you a blow-up picture, all right, of the synaptic gap, the axon terminals, and neurotransmitters. It shows you that gap, all right, and then your reception, the dendrites of the receiving neuron. Okay, and it uses the example of serotonin and dopamine producing neurotransmitters. All right, so we have neurons in our brain that produce specific neurotransmitters, and their job is to communicate those neurotransmitters. Okay, so that's what it uses as the example there. All right, so you have kind of a great resource, a picture to look at, is you kind of a visual image of what we've talked about on the board. Okay, again, it is page 81, figure 9.4 here. Okay. which I have right here. Okay. All right. So that's learning target number 7. Okay. Now we will actually expand on learning target number 7. There's kind of a part 2, which we'll do Thursday and Friday in class. All right. And we'll talk a little bit more about this process. Okay. What happens in the synaptic gap when a neuron fires, specific neurotransmitters that influence behavior, how medication impacts that. Okay. All right. And then we'll do our relay race. Okay. All right. So that's learning target 7 and 6. And you also got instructions on how to finish your lab. So have a good virtual Wednesday. If you need any information from me, again, email me as always, and I will see you Thursday or Friday.